Okay, so let's look at number 8. It says use the definition of continuity to find the values of k or m. In this case, we're not looking for m. We don't have m here. That will make the function continuous everywhere. We're trying to make it continuous. That means all three rules of continuity must be true. Okay? So let's go ahead and establish the rules. Rule 1. We're looking at a certain x value, f of c, and we're trying to say that it is defined. Okay? What you need to first recognize when looking at the two domains is what is this approaching x value. You have the domain here for the first one, everything less than or equal to 2, and then you have greater than 2. So you're basically your focal point, or the x value that you're approaching, is in fact 2. That's like your a value that you're approaching from left and right. So what is f of 2? F of 2 is defined, because we're using the proof, we're going through the steps. It is defined, and we're going to put this x value of 2 right here, so that we get 2 squared is 4. So we're going to say f of 2 is defined right now as 4k. Okay. Second rule, we're going to go to the limit. The limit of f of x, which is our entire piecewise function, as x is approaching this 2 value that we're trying to get, is equal to what? We know it has to exist because we're making it continuous everywhere. Okay? It must exist, and furthermore, it must equal our value that we got for this rule 1, my f of c value, my y output from rule 1. Okay? So we're going to show that it does exist first of all. Exists. And right here you should identify that you have a left-sided and a right-sided limit yet again. If I approach from the left, if I approach from the right, this general limit is composed of two one-sided limits. So let's approach f of x, or let's approach 2 on the f of x function from the left. Then we'll do the same as approaching 2 from the right. We know these must equal each other because, again, we're trying to make this continuous everywhere. So they must equal each other. We're just trying to see what do they equal. Well, if I approach from the left, I'm going to be looking at this function here. And I'm going to put the 2 in there to say that this limit right here is going to equal 4k. If I approach from the right, which is shown here, I'm going to use this function. So when we put 2 in, we're going to get 4 plus k. Therefore, we have 3k is equal to 4. If I solve for k, I get 4/3. So right now, whoops, let me not box in. This will be my 4/3 is the k value. It says use the definition to find the k value. We're just going to quickly identify rule 3 and show that it is true. That way it's continuous everywhere. Okay, rule 3 says basically rule 2 equals rule 1. Alright, so rule 2, we know that these limits existed as one-sided limits because they came from this general limit that existed. So what we can do is say the limit of f of x as a general limit as it approached 2. We can use any one of these functions. Doesn't matter which one we use as long as we show that the k value is in fact 4/3 and that the x value is 2. Okay, so if we use, let's say, the 2x plus k, we'll get 4 plus 4/3, which in this case we'll get 12/3, which we would get 16/3. See, whether we use that one or whether we use the one that was from the left, we would get 4k. Okay, I just used this one right here, and I'm plugging in 4/3 for k, and I'm plugging in 2 for x. Okay, so 4k would be 4 times 4/3, which is 16/3. Notice how these two are equal to one another because we have set them equal way back here so that I could solve for that k. So all this is saying is that I was approaching 2 with my k value of 4/3. It yielded a y value of 16/3. Okay, so that limit, this right here, is equal to 16/3. We're saying that that is equal to what rule 1 would be, whatever this is, times the k value. Okay, and from that, we can say this is f of 2. There's our proof. Therefore, because f of 2, if we plugged in k right here, we'd get 16/3, just like the limit value. Therefore, it makes f of x continuous it makes f of x continuous everywhere. And that would be all for this problem.